Lightning strikes can induce high-voltage surges into electrical systems through several pathways. Firstly, direct contact with the structure. Secondly, nearby power lines or antennas. And thirdly, ground currents. These surges can overwhelm the protective devices in electronic equipment, causing damage. However, the severity and susceptibility to damage can vary depending on equipment design, proximity to entry point, grounding, and circuit wiring. Equipment with poor surge protection is more vulnerable. Equipment closer to the surge entry point receives high voltages. Properly grounded equipment provides a path for surges to dissipate. Thin or old wiring offers less resistance to surges. A neighboring home may not have been affected because firstly, the surge took a different path through the ground. Secondly, their electrical system had better grounding or surge protection. Or thirdly, the equipment in their home was less susceptible to damage. When performing an equipment survey, firstly, inspect all electronic devices in the home, including appliances, electronics, and computers. Secondly, look for signs of damage, such as scorch marks, broken screens, or blown fuses. When evaluating wiring integrity, firstly, visually inspect the wiring in accessible areas, for example, outlets and light fixtures. Secondly, use a non-contact voltage tester to check for live wires that may have been compromised. Thirdly, if there are visible signs of damage or suspected wiring issues, contact a qualified electrician for further inspection. To minimize the risk of lightning damage, consider installing the following protection measures. Firstly, surge protectors. Install surge protectors on all outlets where sensitive electronic equipment is connected. Secondly, whole house surge protection. Install a whole house surge protector at the electrical panel to protect the entire home. Thirdly, lightning rods. Install lightning rods on the roof of the home to intercept lightning strikes and direct them to ground. Fourthly, proper grounding. Ensure that the home's electrical system is properly grounded. Fifthly, regular maintenance. Regularly inspect and test surge protectors and other protective devices. When assessing electrical systems after a lightning strike, understanding surge propagation is critical. Surges don't always follow the most direct path. They can travel through grounding systems, data lines, and even plumbing, seeking the path of least resistance. This explains why one device might be destroyed while another, seemingly closer to the point of entry, remains unscathed. The quality of the electrical installation plays a significant role. Homes with older wiring or inadequate grounding are more susceptible to damage. Modern homes built to current electrical codes generally have better protection, but even these can be vulnerable to a powerful surge. Consider the types of devices that were damaged. Electronics with microprocessors, like televisions, computers, and appliances with electronic controls, are particularly sensitive to voltage spikes. Simple appliances with purely mechanical components are often more resilient. When conducting a post-strike survey, start with a visual inspection of the entire electrical system. Look for burn marks or soot around outlets, switches, and light fixtures. Cracked or discolored electrical boxes. The smell of burnt insulation. Popped or tripped circuit breakers that won't reset. Once you've completed the visual inspection, use a multimeter to check for proper voltage at outlets and fixtures. Pay close attention to outlets that serve damaged equipment. If you find abnormal voltage readings, it's a clear indication of wiring damage. Test the grounding system. A properly grounded system provides a low resistance path for surges to dissipate. Use a ground resistance tester to measure the resistance between the grounding electrode and the electrical panel. The resistance should be as low as possible, ideally less than 25 ohms, as per the National Electrical Code 25.53. If the resistance is high, it indicates a problem with the grounding system that needs to be addressed. Check all surge protection devices. Surge protectors have a limited lifespan and can be damaged by a single large surge. Use a surge protector tester to verify that they are still functioning properly. If a surge protector has absorbed a significant surge, it may need to be replaced even if it still appears to be working. Inspect the main electrical panel. Look for signs of arcing, overheating, or damage to the circuit breakers. If you find any problems, contact a qualified electrician immediately. Pay attention to the service entrance conductors, the wires that bring power from the utility pole to the house. Lightning surges can sometimes damage these conductors, even if there are no visible signs of damage. If you suspect damage to the service entrance conductors, contact the utility company. Regarding protection measures, a layered approach is most effective. This involves installing multiple levels of protection to reduce the risk of damage from lightning strikes. The first line of defense is a whole house surge protector installed at the main electrical panel. This device protects the entire electrical system from surges entering the house through the power lines. Choose a surge protector with a high surge current rating, typically 40 kA or higher. The surge current rating indicates the amount of current the device can safely divert. Install surge protectors on all branch circuits feeding sensitive electronic equipment. These devices provide additional protection against surges that make it past the whole house surge protector. Use plug-in surge protectors with a high joule rating, typically 600 joules or higher. The joule rating indicates the amount of energy the device can absorb before it fails. Consider installing surge protectors on data lines, such as telephone, cable, and Ethernet lines. These lines can also carry surges into the house and damage electronic equipment. Use surge protectors specifically designed for data lines. Ensure that the home's electrical system is properly grounded. A properly grounded system provides a low resistance path for surges to dissipate. The grounding system should consist of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel with a grounding conductor. The grounding conductor should be sized according to the National Electrical Code Table 250.122. Install lightning rods on the roof of the home. Lightning rods intercept lightning strikes and direct them to ground, preventing damage to the structure and electrical system. Lightning rod systems should be installed by a qualified professional. Consider using uninterruptible power supplies for critical electronic equipment, such as computers and servers. Uninterruptible power supplies provide backup power in the event of a power outage and also protect against voltage surges and sags. Regularly inspect and test all surge protection devices. Surge protectors have a limited lifespan and can be damaged by a single large surge. Use a surge protector tester to verify that they are still functioning properly. Replace surge protectors that have absorbed a significant surge. Educate homeowners about the importance of surge protection and electrical safety. Explain the different types of surge protection devices and how they work. Encourage them to regularly inspect and test their surge protectors and to replace them when necessary. When assessing the integrity of wiring in walls, it's crucial to proceed with caution and utilize appropriate tools and techniques. A visual inspection can reveal obvious damage, such as melted insulation or exposed conductors. However, damage can also be hidden within the walls. A non-contact voltage tester is an essential tool for detecting live wires without making direct contact. This device can help identify damaged wires that are still energized. An insulation resistance tester, also known as a megometer, can be used to measure the resistance of the insulation on electrical wires. This test can help identify wires with damaged or degraded insulation. The test voltage is typically 500 volts DC or 1000 volts DC. A low insulation resistance reading indicates a problem with the insulation. A time domain reflectometer can be used to locate faults in electrical wires. This device sends a pulse down the wire and measures the reflections. The reflections can be used to determine the location and type of fault. If you suspect that wiring has been damaged, it's best to contact a qualified electrician for further inspection and repair. Do not attempt to repair damaged wiring yourself unless you are a qualified electrician. Regarding adequate protection, it's important to consider the specific needs of the home and the types of electronic equipment being used. A basic surge protection system may be sufficient for a home with few sensitive electronics. However, a more comprehensive system may be needed for a home with a lot of expensive electronic equipment. Consider the location of the home. Homes in areas with frequent lightning strikes may need more robust surge protection systems. Homes in areas with poor power quality may also benefit from surge protection. Work with a qualified electrician to design a surge protection system that meets the specific needs of the home. A well-designed surge protection system can provide peace of mind and protect valuable electronic equipment from damage. Furthermore, a surge protection system is not a substitute for proper electrical wiring and grounding. An older electrical system is more prone to damage from surges. If the home has an older electrical system, it may be necessary to upgrade the wiring and grounding to provide adequate protection. The National Electrical Code provides detailed requirements for electrical wiring and grounding. Ensure that all electrical work is performed in accordance with the National Electrical Code. Regular electrical inspections can help identify potential problems before they cause damage. Schedule regular electrical inspections with a qualified electrician. During an electrical inspection, the electrician will check the wiring, grounding, and surge protection system. The electrician can also identify any potential hazards and recommend corrective actions. Remember that surge protection is an ongoing process. Surge protection devices have a limited lifespan and need to be replaced periodically. Regularly inspect and test surge protection devices to ensure that they are functioning properly. Stay informed about the latest surge protection technologies and best practices. The electrical industry is constantly evolving, and new surge protection technologies are being developed all the time. By staying informed, homeowners can ensure that their homes are protected with the best available technology. Consider the specific voltage requirements of the equipment being protected. Some electronic equipment is more sensitive to voltage fluctuations than others. For example, computers and other digital devices typically require a stable voltage supply. Use voltage regulators or line conditioners to provide a stable voltage supply for sensitive electronic equipment. Voltage regulators and line conditioners smooth out voltage fluctuations and protect against voltage surges and sags. They can also improve the performance of electronic equipment. Consider the use of shielded cables and connectors. Shielded cables and connectors reduce the amount of electromagnetic interference that can enter electronic equipment. Electromagnetic interference can cause electronic equipment to malfunction or fail. Use shielded cables and connectors for all sensitive electronic equipment. Consider the use of fiber optic cables. Fiber optic cables are immune to electromagnetic interference and voltage surges. Use fiber optic cables for data transmission in areas where there is a high risk of electromagnetic interference or voltage surges. A comprehensive surge protection plan should also include measures to protect against power outages. Power outages can damage electronic equipment and disrupt business operations. Use uninterruptible power supplies to provide backup power for critical electronic equipment. Uninterruptible power supplies provide power for a limited time during a power outage, allowing you to safely shut down equipment and prevent data loss. Consider the use of generators. Generators can provide backup power for extended power outages. Generators are typically used for homes and businesses that need to maintain power for critical functions such as medical equipment or security systems. A well-designed surge protection plan can protect electronic equipment from a variety of electrical disturbances, including lightning strikes, voltage surges, voltage sags, and power outages. Work with a qualified electrician to develop a surge protection plan that meets your specific needs. To elaborate on grounding, it's not merely about having a ground rod. The entire grounding system needs to be robust and properly connected. This includes the grounding electrode conductor, which connects the ground rod to the electrical panel, and the equipment grounding conductors, which provide a path for fault current to return to the source. All metallic components of the electrical system, such as metal conduits, junction boxes, and appliance frames, should be bonded together and connected to the grounding system. This ensures that all parts of the electrical system are at the same potential, reducing the risk of electric shock. The grounding system should be inspected regularly to ensure that it is in good condition. Check for corrosion, loose connections, and damage to the grounding conductors. If you find any problems, contact a qualified electrician to make repairs. The size of the grounding conductor should be appropriate for the size of the electrical system. The National Electrical Code provides tables that specify the minimum size of grounding conductors based on the size of the overcurrent protection device. The grounding electrode conductor should be connected to the grounding electrode with a listed connector. The connector should be suitable for the type of grounding electrode being used. Grounding electrodes should be installed in accordance with the National Electrical Code. The grounding electrode should be buried below the frost line and should be located away from any underground utilities. In addition to a grounding electrode, the National Electrical Code requires that the metal water pipe be used as a grounding electrode if it is available. The metal water pipe should be bonded to the electrical system with a bonding jumper. The bonding jumper should be sized according to the National Electrical Code. If the metal water pipe is not available, another type of grounding electrode, such as a concrete encased electrode or a ground ring, can be used. Concrete encased electrodes are installed in the concrete foundation of a building. Ground rings are installed around the perimeter of a building. The location of the grounding electrode can affect its effectiveness. The grounding electrode should be located in an area with moist soil. Dry soil is a poor conductor of electricity, so the grounding electrode will not be as effective in dry soil. The grounding electrode should also be located away from any sources of electrical noise. Electrical noise can interfere with the operation of electronic equipment. Properly installed and maintained grounding system is essential for electrical safety and for protecting electronic equipment from damage.